Hello! Salut! Welcome to Mathman channel. Bienvenue sur la chaîne de Mathman. Today it's basic math and today it's episode 16. Donc, bienvenue sur la chaîne de Mathman sur les maths de base. Aujourd'hui, c'est l'épisode 16. Okay, so let's make a quick review about what we have seen about algebra and functions. Donc, faisons un petit récapitulatif sur ce que nous avons vu sur l'algèbre et les fonctions. So, first of all, we've seen this kind of function, f of x equals m times x plus p. Donc d'abord nous avons vu ce type de fonction f de x égale mx plus p, with the example of the conversion between Fahrenheit degrees and Celsius degrees. You remember? Y equals 9/5 times x plus 32. So which means m equals 9/5 and p equals 32. Ok. Donc nous avons vu comme exemple la fonction qui permet de faire la conversion entre les degrés Fahrenheit et les degrés Celsius, qui était y égale 9 cinquièmes de x plus 32, donc c'était m égale 9 cinquièmes et p égale 32. We have solved some equation like this, m times x plus p equals c. Donc par exemple 9 cinquièmes de x plus 32 égale 40. So let's solve this equation and analyze what are the steps. First steps, we have to subtract this number on each side of the equation. So in order to get the part with x only. Okay, so here it is, m times x equals c minus p. And second part, we have to divide by this number. And so we've got this. In practice, we have to multiply by the reverse fraction. So we get 40/9 divided by this number. So, alors, donc ici on a divisé par 9 cinquièmes, ce qui revient en pratique à multiplier par 5 neuvièmes. In general, we have to divide by m. So we can have a formula to solve this kind of equations. Donc nous avons une formule qui nous permet de résoudre ce type d'équation. Okay, but let's assume that we have a room like this, a square room. Donc supposons que nous avons une pièce de forme carrée. And we know the side of this room. And we are interested by the area of this room. Donc on a une pièce de forme carrée et on connaît l'un des côtés et on s'intéresse à l'aire de cette pièce. So, the function related to this area is called a of x equals x to the power 2, x to the square. Donc l'aire d'une pièce carrée, connaissant le côté x, eh bien c'est x au carré, x à la puissance 2. So that's another kind of function. So let's assume that this is a room, so x is necessarily a positive number. Donc puisque c'est une pièce et que x est la longueur d'un côté de la pièce, c'est forcément un nombre positif. So let's compute some of this. We've got x here and we've got x to the square here. Donc, calculons quelques valeurs. Ici, nous avons x, et ici, nous avons x au carré. So, for x equal to 0, x to the square is 0. For x equals to 1, x to the square is 1. For x equals 2, x to the square is 4. For x equals 3, x to the square is 9, and so on. Okay, so now let's make a graphical representation. So let's use GeoGebra. Donc on a calculé quelques valeurs comme ça, et on va faire la représentation graphique. Donc pour ça on prend GeoGebra, and we write a of x equals function, and let's precise that x to the square, and from 0, let's say, for example, to 5. That's enough because, as you can see, it's grow fast. Okay, let's change the scale and say we have to go to 25 for y. Okay, and for x only until 5. And let's start to 0 here and to 0 here. Or let's put a margin here like this, and here like this. Okay, so we've got this curve. This kind of curve is called a parabola. Donc nous avons une courbe, et cette courbe est appelée une parabole. Okay, now we can get more abstract things. Okay, it was the area of a square, so okay, a side of a square is a positive number, but let's think about what's gonna happen if we allow x to be a negative number. Donc nous avons vu que ça c'était l'aire d'un carré, donc c'était à partir d'un côté. Un côté d'un carré c'est toujours positif, c'est une longueur géométrique, mais montons en abstraction et regardons ce qui se passe si on autorise x à être un nombre négatif. Let's do some calculus. Okay, so we do the same table, but this time we focus on negative numbers. If we choose, for example, -1. -1 to the square is equals to -1 times -1. When we've got an even number of negative sign, we've got a positive number. So -1 times -1 equals 1. Donc quand nous avons un nombre pair de nombres négatifs dans un produit, le résultat est positif. Donc -1 fois -1, on obtient -2 times -2 equals to 4. -3 times -3 equals to 9, and so on. So what can we observe? We can observe a kind of symmetry, because that's the same as the positive numbers. If we look at positive numbers, we've got the same. Let's say that's -x, and let's look for here. 1 to the square is 1, 2 to the square is 2, is 4, sorry, 3 to the square is 9, and 4 to the square is 16. So 1 to the square is the same as -1 to the square. 2 to the square is the same as -2 to the square. 3 to the square is the same as -3 to the square, and so on. -x to the square equals -x times -x. So it equals to x to the square. Donc, ce que nous avons montré, c'est que lorsqu'on prend les nombres négatifs et qu'on les met au carré, on obtient la même chose que le nombre positif au carré. Un carré est toujours positif. Okay, let's change our function and say that just x to the square, and so let's change the scale. No, not this. Let's change scale, sorry. Here it is. And here we go. We can see a symmetry. We can see a symmetry with this axis. We can see a symmetry between these two axes. Let's take this guy and let's ask GeoGebra to build the symmetrical, and here it is. We can compute this easily. We can compute this easily by taking this guy, and we can build an isosceles triangle. Let's calculate this length and this one. For this, we can use the same technique as yesterday. Up, here it is. We use the perpendicular here and the perpendicular here, and we've got two rectangle triangle, right angle triangle. So we can use Pythagoras formula. We have the right angle triangle BCO and the right angle triangle DB prime O. So let's do this and then do this. Okay, so here we go. First we've got BCO. Okay, so we don't get a value to B because that's just a point on the curve, and the equation of the curve is y equal x to the square. So B has for coordinate x to the square. Okay, and we've got this triangle BCO. Okay, and C has got for coordinate x0. Okay, so we've got this length is x and this side is y. That means x to the square. That's x to the square x. We can compute this. Okay, here we go. We've got thanks to Pythagoras, let's write it, Pythagoras. Donc ici nous avons un triangle rectangle en C, d'accord, et nous avons cette distance là qui fait x et celle-là qui fait x carré. Parce que ça c'est l'ordonnée de B et ça c'est l'abscisse de B. So let's use Pythagoras. We've got BO to the square equals CO to the square plus CB to the square. So that means we've got x to the square and plus x to the square, don't forget, parentheses. So that means x to the square plus x to the fourth. Or if you prefer to factorize, we can write this x to the square factor 1 plus x to the square. Okay? So when we compute BO, that square root of that. Okay. So it's, remember, property of square root. If you don't remember, look at the video about square root. So it's equals to that. Okay? The positive sign. Because if x is negative, it could be minus x. If x is positive, it will be x. Okay? Okay. So now let's have a check on the other right angle triangle. The other right angle triangle is, I have to say something. Here it was minus x. Okay. Why? Because here it's minus x. It's just for not being no problem, because on the left that's negative numbers and on the right that's positive numbers. That's why I choose this. Donc j'ai mis moins x ici parce que le b je l'ai mis à gauche, et à gauche c'est les nombres négatifs et à droite c'est les nombres positifs. X pourrait prendre n'importe quel signe, mais pour pas qu'on s'embrouille l'esprit, je garde moins x à gauche et je mettrai plus x à droite. So, okay, and now let's look on the other triangle, other right angle triangle. It's D here, O, and B prime. B prime has x to the square. Okay, so it will be easier. That's the same. We use Pythagoras. So we've got b prime to the O to the square equals OG to the square plus db prime to the square. So which is equal to x to the square and x to the square to the square. So that means x to the square plus x to the power 4. And as the same, we can factorize and put x to the square factor 1 plus x to the square. So that's the same calculus, and we get the same length, b prime O without square, sorry, which is equal to x times square root of 1 plus x to the square. So let's just have a look here. It's this. Okay, so we've got the same length, BO equals B prime O. That means BO B prime is isocel. Okay, so it's an isocel triangle. That means the vertical height from O is a symmetrical axis of this triangle. Okay, we can easily compute this point. It's easy to know its coordinate, because that's 0 on x-axis, and that's precisely x to the square for y-axis. Okay, and we know that for this it's minus x, and for this it's x, so distance here is x, distance here is x. So that means this guy is the middle of this line, and because this guy is at the same distance of this guy and this guy, that means this line is a symmetrical axis. So we have proved that a parabola has got a symmetrical axis. Okay, so let's summarize what we have seen. We have seen a new kind of function called a parabola function, quadratic function. A to the x equals a of x equals x to the square. Donc nous avons vu un nouveau type de fonction qu'on appelle les fonctions quadratiques, la fonction carrée, dont la représentation graphique est une parabole. And we have remarked that a of minus x equals a of x implies symmetrical axis. symmetry. Okay, this is that's yet for today. Just think about, we have x to the square, but what could be the reciprocal function? We'll see on the next episode. See you tomorrow.